5.7. Second law aspects of refrigerations and heat pump cycles interacting with two reservoirs. A refrigerator is a continuously operating device to transfer heat from a low temperature to a high temperature. So we'll draw a schematic for a refrigeration system. So this is refrigeration system. So it operates between two reservoirs, hot reservoir and cold reservoir. Heat is transferred from the cold reservoir. And here we have QH going up to the high temperature heat source. Naturally, heat is not transferred from a low temperature to a high temperature. So work needs to be provided to make it happen. So work provided is QH minus QC. So this is a refrigeration system. Similarly, heat pump is a continuously operating device to transfer heat from a low temperature to a high temperature. Both refrigerator and heat pump work in the same way. The performance of a refrigerator is determined by the coefficient of performance, or COP. It is defined as the heat transferred over work input. So we use symbol beta to denote the coefficient of performance for the refrigeration system. Heat transferred QC. And the required work is QH minus QC. So the basic idea to define the coefficient of performance is desired output QC over required input, or W. The coefficient of performance for the heat pump cycle, we use gamma to denote the coefficient of performance for the heat pump. Heat transferred is QH. It's not QC, but QH for the heat pump cycle. Divided by the required work, QH minus QC. So we need to distinguish between the refrigeration cycle and heat pump cycle. Although both work in the same way, the primary objective of a heat pump is to produce heat, QH. It is the heat added to the high temperature space. On the other hand, the objective of a refrigeration system is to remove heat, QC, from a low temperature space or refrigerated space. So we use QH for the desired output for the heat pump. And we use QC, the desired output, for the refrigeration system. So they are different in terms of the purpose of uses. Countercurrent can be also applied to the refrigerations and heat pump cycles. They are very similar to countercurrent for heat engines. The first, the coefficient of performance of an irreversible refrigeration cycle is always less than the coefficient of performance of a reversible refrigeration cycle when they operate between the same thermal reservoirs. The second, all reversible refrigeration cycles operating between the same two thermal reservoirs have the same coefficient of performance.